Yes, I think we can start. So, welcome to my little talk called How Hacking Works. Way more people than I actually expected, so that's super awesome. My fear was actually that nobody would show up, and I was standing here talking to nobody. So that first crisis is averted. So before we get into all the details, let me just start with this obligatory slide. Who am I? And why should you listen to me? This is usually where people list up all their accomplishments, all their education, everything they've done in their life, and why they have merits. I don't have any of that, so I'll just state my name. It's Espen Sande-Larsen. I've worked as a developer, tech lead, architect, and a hacker for the better part of 25 years. I'm also a musician. I release my own music. You can listen to it on Spotify. #shameless plug, or don't listen to it. I'm the father of 3, and I am insanely occupied and interested by technology in all aspects and forms. So my hobbies are also the stuff I work with. So I do programming, hacking, hardware tinkering. I do fly drones. I do music, and I also really enjoy drinking beer and talking to people and having fun. I work at this little bank called DNB Bank in Norway, in a division called New Tech Lab, which has nothing to do with banking. I don't know anything about banking. New Tech Lab is more this kind of R&D department, so I get to tinker with technology and build experiments and research new stuff. And currently I'm working with quantum computing and encryption and doing experiments to visit how you can create quantum proof encryption for the future, which is pretty interesting. Since I work for a big bank, I have to do this disclaimer thing, which is legalese, basically saying that everything I'm about to say, it's me saying and not necessarily what DNB says. If you want to read it, it's there. I'm not going to go through it. Everything I'm saying is just me, my opinions and my experiences. I got started into computing when I was a kid. I started with this marvelous machine. Some of you may have seen it. Some of you may think, what the hell is that thing? Where's the screen? So that is a Commodore 64, which was an awesome 8-bit computer. I got it when I was 6 years old. My big brother traded some drugs for a Commodore 64, and that's how we got that into our house. I think of that as the drug deal of the century, because it got me hooked on computing and not drugs. There's one problem, though. When you get a computer on the black market, you don't really get the best support agreement with your computer. So you just got the power cable, the antenna for the RF modulator, and the computer itself. So no manuals, no games, no software, no nothing. And we had to figure out how that thing worked in order to make it do stuff, because those kinds of archaic computers didn't really have a software package, a nice operating system, and all that stuff like modern computers do. So it essentially had an interface, which basically was a programming interface for the machine itself. So we had to figure out how it worked, how its memory model worked, how you can access all the hardware features and stuff like that. And that is how I learned computing when I was a kid. That journey of discovery through curiosity, figuring out how that machine kind of set a tone for the rest of my life. And it kind of gives me an advantage into these kinds of things that I'm about to speak to, because it triggered my curiosity, which is essential, the one ingredient for how you can pursue these kinds of endeavors, that is hacking. But before we go more into hacking, we have to define what it is, because it used to mean something different. And what better way of figuring out what hacking is to check out what Hollywood has to say about the issue. So this is a show called NCIS, and they have this is a government agency. They are being hacked in this scene, and they have to defend against it. And how do you do that? Well, let's see.
No way.
So they're being hacked. The way you know you're being hacked, there's a million pop-ups on the screen. And you defend on the keyboard in real time. And what's better than one defender on one keyboard? That's 2 defenders on the same keyboard. Because that is how keyboards work.
he or she is only going after my machine.
It's not possible.
Important to not call it he, it has to be he or she. And now a guy comes in with a sandwich, trying to help.
Something McGee.
And of course, the one person in the room who is non-technical is the one who saves the day.
Where'd it go?
And how did he save the day?
I thought you did.
No. I did.
By unplugging the computer, because in this government agency, all essential data that the hackers were after was in that single terminal in the laboratory. So that's how that works. Okay, so that's nonsense. Let's check another TV show. This is, they have to do it right. This is CSI, so it's about forensics and investigations. Surely they did some research.
Weeks I've been investigating the Cabby killer murders with a certain morbid fascination.
This is in real time.
I'll create a GUI interface using Visual Basic. See if I can track an IP.
I'll create the GUI interface using Visual Basic and see if I can find an IP address. I don't know how to comment on that. So how about a movie that's called Hackers? They had to do research, right? So let's see. Well, by the looks of that keyboard, maybe not. Let's see. So they are hacking this corporation.
There's a new virus in the database.
What's happening?
And they send a virus that eats the memory like Pac-Man.
Type cookie, you idiot. I'll head him off at the pass.
You have a zero bug. Attacking all login and overlay files.
Run antivirus. Give me a systems display.
And of course, to defend using 3D interfaces, shooting the hackers with lasers.
Dickweeds.
Yeah, take that, you hackers.
It's in the administration system.
Send a flu shot.
Rabbit, flu shot.
That's
Someone talk to me.
not a thing.
Replicates till it overloads a file, then it spreads like cancer.
Cancer?
Yeah, no. So again, I don't know how to comment on that. It's so awful. How about a show that is about the life of an actual known hacker? They had to do some research. No, they didn't. So in this show, they have malware running on an airplane, and they have to patch that airplane. And of course, there's only one way to do that. You race after the airplane with a Ferrari while in flight. And some poor member of the flight crew has to go down on the landing gear with an Ethernet cable to plug in to patch the plane. So yeah, we have the cable. We can patch the plane. If only we had more runway. So how do you solve that? Well, the plane has to clear the tower. Well, I guess you have to stretch. Yeah. So this is how hacking works, right? Well, all of this is nonsense, and I guess they have to make it interesting to a viewer who has no technical knowledge, but I think they could do a better job than these displays. Anyways, let's talk about what it really is. So it used to mean something different. The word hacking actually used to mean tinkering with stuff, building computers and software, and trying to make things work outside their intention. So kind of, let's say you're trying to build a computer, but you only have these parts. Can you make a computer do more than it should? That's basically what they call hacking. Or can you make this program behave differently by doing some modifications to it? My favorite example of this is Steve Wozniak, who managed to build the color output for the Apple II by actually, instead of using a color chip or a video chip, he figured out how to manipulate the video signal that misaligned the ray cannon, and that caused colors to be displayed on the screen. And that way you could make a computer with a color output without any video chips. But what we refer to as hacking today was originally known as phreaking, or with a PH for phone phreaking. Because back in the day, in the 70s and 80s, in order to communicate with computers, you actually had to dial them up and call them up on the phone. Because we used the phone lines for communications back then. And if you knew how phone systems work, how Phone Central works, and you can manipulate them to route your signals and stuff like that, and you can manipulate the modems on your remote, the computers you access remotely, and you can gain access to computers, that was known as phreaking. But in the essence of this talk, what we are talking about when we're using the word hacking is just exploiting systems through their vulnerabilities. And this talk can take a couple of different turns. So let me just take an audience poll. So if you agree with the statement, just raise your hand. So how many are programmers, coders, developers, or whatever the current name you write code for? Okay, most of you. Any tech leads, architects, solutions principals? You like design the systems, not necessarily code them? Okay, some of you. Any security engineers, pen testers, chief security officers, hackers? Okay, awesome. How about something else like a Scrum Master or project manager or management in some way or form? No. Oh, okay, we have one. Okay, you're a brave soul. Awesome. We know what we define as hacking, but there are also different kinds of hackers, and you know what kind of motivations they have based on the color of their hats. So you can just look around in a room of hackers, and you can pick out all the different ones based on their hat color. Of course, they don't really wear those hats, but it's carried over from the old westerns where the good people had white hats and the bad people had black hats. But we have some more hats. So the black hat is the classic malicious hacker that does the bad stuff, and we have the white hats, that is the ethical hackers or the pen testers or people doing stuff for good. And then we have like the middle ground, people who are not necessarily malicious, like these are the gray hats, but they may not necessarily also be ethical. For instance, they may search for bugs or hacks in systems they don't have permission to do so with, but they will disclose those things if they find it for a reward or hope for a reward. Then we have green hat hackers, and that are just new hackers who are starting their journey, which is what I hope to make all of you into by the end of this talk. And then we have the red hat hackers. They are not necessarily Linux fan people, but they are people who hack other hackers and hunt other hackers and take down big hacker organizations. And then we have the blue hats, which are hackers who are invited by organizations to test their systems prior to release. For instance, Microsoft has a long history of hosting in-house blue hat events where they invite hackers to test out new versions of Windows and Office before they release them. And this way they find the vulnerabilities long before they are released to the public. So now we know hackers and what hats they wear, but why do these hacks actually happen? And that is, the sad truth is basically we are developers and we are humans, so we make mistakes. And those mistakes are not necessarily something we would do on purpose or because we have any malicious intent. It could just be that we haven't thought of everything. And sometimes these systems we build are quite complex, and the devil is in those tiny little details that you may not have been aware of. And once you see some of these things happen, after the fact, it's pretty easy to see what went wrong, but before they happened, this is something you rarely would notice. Another thing that makes hacks happen is that nowadays we trust other people's code like it's the best thing ever. I'm talking to you JavaScript people, if there are any of you out there, because we get packages, libraries, and we just use them. We don't vet them, and we think that they are safe and nice. Back in the old days, we didn't do that. We wrote everything ourselves. But these days, we need more complex systems with more features, and it's easy to use repackaged code that other people have done for you. And also, we developers, we kind of like our tools. Sometimes we get like religiously involved in our tools. It's like we have a hammer, and we only want to use that hammer for everything. Even if we want to build a foundation for a house, we still use the hammer to mix the cement instead of getting a cement mixer. And that is the same thing we do with languages and platforms and libraries and stuff. We tend to try and use our tool of choice for everything. And that may not necessarily be the best idea. And I really know this because this happened to me once. Yes, I really got hacked once. Not personally, but at my work. And this cinnamon bun advert is going to make sense in a bit. So what happened was that I was hired to be the CTO in a startup, small startup. We were going to take over the world. We were going to build this solution that everybody would want. It would be this hockey stick growth of the company, and we will all get rich. The thing is, this system was supposed to use ads on e-newspapers, web newspapers, and we were going to use those as like advertisement channels. So we can send adverts to all e-newspapers in Europe and North America. And this was a quite ambitious project. And also when you're in the CTO in a startup, you're also the tech lead and the principal architect. And this was way before there were any clouds. We only had boxes. And I had to build a distributed real-time system that would work equally well in the Netherlands as in Norway. So I had to travel around Europe, set up data centers and boxes, and get this thing working. And there was this one tiny little detail in this thing that made it all fall, and that is because back then, there was only one way to create like rich content on these on websites, because one of the main ideas of this thing was that we can have games in the adverts and you can win prizes, and that would trigger engagement from the audience. And there was only one thing back then you could use, and that was Flash. And you may know Flash. If you don't know Flash, here's a crash course. It was this thing. That's the IDE. How many of your current IDEs have drawing tools or a timeline for animation inside? So that kind of hints to it. Even though we have some code here, there's probably something else going on. And Flash was intended to create like interactive presentations that you can like send to somebody on a CD or some kind of media, and you can create like a corporate presentation, and you can react to actions from the user. Or you can build games, or you can build animations. What it wasn't intended to do was to handle anything that had any transactional value, which is what we used it for, because we used it to have the game, and then it made a backend call once you have won the game, and then you got the barcode sent to your phone that you could use to get a prize. And Flash was compiled into a binary format, and it ran in your browser. So I thought that was fine. The one thing I didn't know, it was pretty easy to reverse engineer. You can decompile it, and you can find the backend call, and if you have that backend call and the signature you use to use it, you can generate as many prizes as you wanted. And there was one Swedish student who did just that. He decompiled the binary, he made the backend call, and he spread that backend. He created a little application called Bulleautomaten, which is spread to his university, and people could just like use that app to get like infinite amounts of cinnamon buns. So basically, I think I fed the entire student body of Sweden for a couple of months. And they generated the ticket. They can go to the convenience store, scan that in, and they would get their cinnamon bun. And I got a call early in the morning from my CEO, who was furious. It was like, hello? Oh, Jesus, that was awful. And the CEO was yelling continuously. And I can pick up one detail, that was one person had picked up 73 cinnamon buns in one single day. My immediate response was that person really enjoys cinnamon buns, which my CEO didn't think was pretty funny. And I got called into this awful meeting in front of the board, and everybody was mad at me, and I had to like, okay, it's my fault, I'm liable, I'll fix it. But then I got like sick of getting yelled at, so I thought I have to spin this in some way to make it more positive. So I said, no, we're not going to keep a lid on this, we're going to be very open. So I said to the CEO, you go to Sweden with a big case of cinnamon buns, you find this student, and you take the biggest newspaper, and you make a story where you present that case and thank this person for figuring out the vulnerability. And that happened. And then we had this 2-page spread in the biggest newspaper with the hacker and our CEO going like this. So that was the happy ending. And I gave this talk earlier this year, and one person came up to me and said, I used to study in Sweden during this time, and you fed me through my second semester. And he also told me that he had used this event in his master thesis, and he later used it for his PhD. And now it's in the textbooks for the technology students in Sweden as what not to do. So I am actually a textbook example of what not to do, which is I think is kind of cool, because I failed, and not only did I learn, but I get to learn generations of people through my failure. And how can we actually prevent against these things? Because usually these things happen because people do things or systems that we didn't think they would do. And one great way to do so is to kind of build these adversarial techniques and the adversarial mindset into your dev team. Because if you know how hackers think and you actually try and hack your own applications, it will actually make your applications more secure. And one great way of doing so is something called CTFs. And I'm going to let Elliot from the awesome TV show Mr. Robot, which is actually the one TV show where they actually did research and they portray hacking in a very realistic way compared to the other ones, tell you what a CTF is.
A CTF tournament, capture the flag. It's like the Hacker Olympics. Teams around the world compete to solve challenges, reverse engineering, protocol exploitation, forensics. The entire city suffering an energy crisis while they're here exercising their inner anarchy.
Yes, so it's like the Hacker Olympics, and you can exercise your inner anarchy, which is pretty cool. So anyway, how many are familiar with CTFs? A few, okay. So for those of you who are not familiar, let me go into what they are. So CTFs, it stands for Capture the Flag. It's kind of a contest where you get to exploit systems and hack them and find a secret. And if you find that secret, you can exchange that for points, and there's usually some kind of prize involved, or a scoreboard at least, or something, a way of gamifying it. And these tasks are all centered around one single aspect of hacking or one single aspect of security, and they're usually tuned to kind of teach you that concept. And the cool thing about CTFs is they are really engaging, and it's an incredible catalyst for learning these things. And it kind of gets you going and starts your learning journey so that you work in increments and you build these skills step by step. And the cool thing is, once you start to doing this, you start to think differently, and you kind of view your applications and your systems differently too, which is kind of fun, because you start trying to apply these techniques to your own systems. Maybe if you do it right, you can discover some vulnerabilities that you hadn't caught before, and that is a value. And you do this by solving these challenges. And the cool thing is that if you do this in your team, it creates engagement. We actually did this in the entire DMB group, not just the technical department, but across the entire group. And we got some great engagement, and we got some awesome water cooler conversations about security and hacking with people who you necessarily wouldn't thought about these things. And actually, my favorite email in DMB that I got was when we had our CTF the last time. I got an email from a lawyer in the legal department. It was a letter of apology because he had performed a SQL injection attack and accidentally deleted my database. So he wrote a letter of apology, how sorry he was for doing so. And I thought to myself, when lawyers in the legal department are performing SQL injection attacks in a bank, you're doing something right. That's pretty cool. Because it is so really fun to be the villain for once and actually be trying to be a bit bad. And CTFs usually organizes their challenges in categories. They are usually these are the categories themselves kind of tell you what type of challenge it is, what tools you may need to use to solve them. For instance, we have crypto. It's not about cryptocurrency, but it's about codes and encryption, and it's about breaking them. That can be as simple as a substitution cipher, and it can be as complicated as RSA or any other encryption scheme. And usually there is some kind of vulnerability in the way it's encrypted that you have to use to break it. Then we have Stego, which is kind of the step brother of crypto, which is where you hide information inside another piece of information. So it could be like a file embedded in an image that's not necessarily visible, or it could be something hidden in a file system. It can be whatever you hide inside something else. And then we get up the ladder, we get to forensics, where it's all about finding secrets in data. And so it could be like network logs, it could be whole system dumps, it can be other logs, whatever. And you search for clues, and that's where you find them. Then we start getting into the real hacker territory, and that is reverse engineering. That is all about binary exploitation usually, but it's all about figuring out how an application works and how you can manipulate it. So it's kind of like old school password cracking. If you've had a stab at that, that's often how that works out. Then we have vulnerabilities. That's usually about known vulnerabilities often in third-party code or in concepts, where you exploit somebody who's doing something in a way they shouldn't do. It could be like a known one from the CVE database. If you're not familiar, that is a great place to find if you're building these kinds of tasks. It's known as the common vulnerabilities and exploits. It's a database online. Whenever a new exploit is found and disclosed, it's given a code based on the date, and it's then an incremental number, and it's published, and usually you can find proof of concepts to how to exploit them, which software and which things are afflicted by it. Yeah, and it's a great place. And there's often a web category, which is all about the juicy bits of the web, where it can be JavaScript, it can be PHP, it could be anything that has to do with web applications. And then there's the creme de la creme. That's the pawn category. That's where you actually get to take over a remote service and actually gain shell access or a way to execute arbitrary code. And that is the kind of the one that every the other tasks build up to solve. That's usually the most difficult ones. Also one of the most fun ones. There are several tools you can use. I'm not going to go through them all because there are many more tools. This is not an exhaustive list, but there's some there. One is Kali, which is a nice turnkey system where you have a bunch of these tools already installed. It's a distribution of Linux. There's Pawn Tools, which is a Python library that does binary exploitation, which is kind of awesome. It's also good old GDB, the GNU debugger, which is kind of cool. Ghidra, which is a gift from the NSA to do reverse engineering. It's this internal tool from the NSA that they use to do reverse engineering. I'm going to show you that in a bit because it's freaking awesome. Why they're giving it away for free, I don't know. But they did. So enough talking, let's do some demos. Let's see what this thing is all about. So I think I need to do this. Yes. Let's hope we have enough time. So I'm using Windows, sorry. But I'm using WSL, and I have my Kali Linux running on this machine, and I have some demos to show you. So I'm going to start with some reverse engineering and binary exploitation. This is called. We have a file called ROPME. If you went to the previous talk, she actually went through how this thing works in much more detail than I'm going to do. But I'm just going to show you a simple ROP chain. ROP stands for return-oriented programming, and it's a way to kind of, when you can't overflow executable code onto the stack, what you can do is you can write return pointers to different instructions in memory and kind of build a chain of code you're trying to execute. And you do that by overflowing pointers to the space that has the instructions you want. So let's check out this thing. So we have a file. It's a 32-bit ELF executable. It's not stripped, so we have some symbols and stuff we can use to make things a bit more visual. Usually when you do CTF challenges, you don't get so simple binaries. So I made this simple on purpose, just so it's easier to demo. We can also check if there's any compiler fortifications on the file. So let me see. We can see that we have no red row, there's no stack canaries. There is the no executable flag, so we can't execute stuff on the stack. And there's also no position independent execution, so meaning that the memory map of the program will be the same cross execution, so it won't randomize the space the program is running in. So let's just do open this in GDB to see what we have. So let's see if we can find some functions. We can see we have 3 functions. We have main, we have vulnerable, and we have win. We can disassemble main and see the instructions. How many of you know assembly? Just by show of hands. How many of you think assembly is quite painful and hard to read? Okay, yeah. Just breathe, relax. It's not that difficult, and you don't necessarily need to know exactly what everything does. There are just some kind of key things we need to find. So this is the main function. The thing that is interesting is right here where it pushes a pointer to a buffer on the stack, and then it calls scanf, and that means it takes my input. Then it pushes that input onto the stack again, and it calls the vulnerable function. And that's the important bits. I can set a breakpoint. So where's my star? There's my star. At the address where it calls the vulnerable function. So that is 080492 F3, I think. Yes. And let's check out the vulnerable function. See what that does. So that is not that much. It takes. So what happens? It seems like it pushes another buffer onto the stack, and it copies the one that it got in through string copy. It calls printf to print out that buffer, basically. So that is pretty simple. And then we have a return instruction here where it returns back to main. So let us set a breakpoint at that return instruction, because that is the gadget we're going to use to be able to call a different function, because there are no calls to win here. So what we are aim to do is, instead of returning back to main once we hit that instruction, we want to return to the win function and execute that before we exit. So that is the goal. And that is 928C. Very correct. If I just run this now, it says, yo, enter your name. My name is Espen. Now we hit the first breakpoint. It's about to call the vulnerable function. You can see there. This is where we are. We can see my name is now on the stack. So if I do one step into, we can see that we are now inside the vulnerable function. And we're about to do that copy thing. And if we do one continue, we now printed Espen, thank you for running this binary, on the screen. And we are now at the return. And we can see now that at the top of the stack, the address to the point in main that is after our function call is where we return to. So we want to change that. We can change that by taking some input. So I'm going to use Perl, sue me. It's fine. So let's see, I have to get my codes done. So I'm going to print, and I'm going to do A times 100, and I'm going to concatenate that with 4 Bs. So now the thing that happens now is that you can now see that on the stack, we have those Bs. Didn't I do that correctly? Is it like this? Yeah, not time, it's X 100. So we can see I have a bunch of A's 100 times and 4 B's. If I continue into the return instruction, which is there, nothing happened. So it still returns back to main here. So I need to overflow this buffer more. And there are tools where you can actually figure out these offsets and calculate them, or you can read the code and see how big the buffer is and stuff like that. For a simple example, I'm just going to wing it and experiment and do incremental development, I guess we can call it, by just guessing. Now we can see something interesting happened. So now I have 0804, and then I have port 242, so I have two Bs in this return address. So if I continue now, I will get a seg fault because it doesn't know where that address is in memory. It doesn't exist. So I can see that I only managed to overwrite 2 bytes of that address. So I need to add 2 more bytes. So just add 2 more A's. And now I can see that I have BBB on the top of the stack, which is where it's going to return to. So I continue now. It says that B42 is B, is an invalid address. Now I can do something fun, because if I do print on the win function, I can find the address to the win function. So if I now take my input, and instead of BBB, I do this address, and it's a little ending, so I have to do it in reverse. So it's D6 91 04 08. And we see now that we have the 112 A's, and now I have this bunch of nonsense here, which is that memory address. We continue. I can see now I'm at the return instruction, but now we can see that the address on the top of the stack, which is where it's going to return to, is now the win function. So if I step now, you can see that I'm now inside win. Now if I continue, it will print out uwin, which is what the win function does. So I now managed to manipulate the control flow of this program by overflowing over that return pointer, which is quite neat. So that is one way of doing binary exploitations. There's more ways. And I'm going to show you an awesome tool called Ghidra, because we have another file called Jedi Mind Trick. Like this, and you can see it's a 64-bit ELF this time. If I run it, again, it asks for my name, and it says, hello there, Espen, and I get a message. In CTFs, flags always have a format, which is how you know that this is the piece of information you're looking for. So in this CTF, it's always, all the secrets are formatted like this. It's $, and then curly braces, and the secret is inside. So this is what we refer to as a flag in the CTF. However, the bad thing with this is that if I run this every time, I will get a different one. Hopefully I will get one. Yeah, so I find your lack of printing disturbing. These are not the vars you're looking for. So unfortunately, those are not the real flags. These are decoy flags. In order to get the real flag, we will have to do something else to this program. One way of doing these things can also be to check for strings. Let me just do that quickly. You can see all the names of the functions we link to, and a bunch of other stuff. And here we can see these are not the words we're looking for, but and all these decoy flags. And it says hello there. Let's investigate this further. We could do this in GDB, but I'm going to show you another awesome tool, which is called Ghidra from the NSA, which is a great piece of software that you can use to reverse engineer. You can use it to build the patches and cracks and all great fun stuff you can do with binaries. One of the cool things about Ghidra is that not only does it disassemble your program, it can also decompile it, meaning you get like C-type syntax instead of assembly. Let me open that in Ghidra. It's figured out it was a ELF, and I get some information. which I can just ignore at this point. So let me just open this. Come on. Okay, my machine is just, so I can just analyze it. All of this is so now it will just analyze this binary, and it will find stuff like functions. It will figure out what functions I've linked to. It can find labels and strings and all that fun stuff. But if I go into functions, I can see main. And not only do I get the disassembled assembly for this program, but I also get C-like syntax. And it's pretty C-like. You could actually almost copy-paste it and get it to compile. It did mess up a bit because either it messed up or this thing has been optimized. But you can see there's this array here, which points to different flags. These flags are the ones that we saw here. So it's just a string, you can see here. And it gets a random number, and then it just gets your name, prints out your name, and then it prints out a random of these decoy flags. So now, anybody spot anything with this code that looks particularly dangerous? I don't know if it's easy to see. Can I zoom in? So there's one, I've seen code like this go through code reviews and straight into production systems because it looks quite benign, but this is the thing, that's the culprit. So I do a printf and I just pipe in the same buffer that I just read into. I don't do any checks. I don't do any kind of checking if what that input is. And if you just take that to printf, that can be dangerous. Why, you may ask? It's because printf is a function that can format strings, and it does that by you specify a format specifier. Printf then expects the value to be interpreted using that specifier. It's the next thing on the stack, so it pops that off and tries to interpret that value. If you don't specify an argument for the value, but you give it the format specifier anyways, well, printf won't check if that argument was given. It would just try and interpret whatever is on the stack as that value. So we can test that out. So if I do Jedi mind trick, instead of poking my name, I'll use the format specifier for a string, and then I get a seg fault. It didn't like that. So how about if I do an integer? So I got 32. That means that whatever was on the stack is now evaluated, and it's the number 32. And this can be dangerous. And another cool thing about this specifier, it doesn't have to be the first element. It could be like, let me see, the fourth element. Then I get a different number of that thing. And let me see, this service is now running remotely in the cloud as a service, and I'm going to exploit that remote service using this very vulnerability. So let me just see, let me just cat out Jedi remote, so that this is the remote address. I can just copy that. I can do a netcat to that, and I can see it's the same thing. And I've created a little exploit in Python using pawn tools. So it's pretty easy Python. It's a for loop from 0 to 200. I access that remote service, and I take that I and create a numbered format specifier and ask the server to send that, and whatever it replies, I'll get back. And I will do that over and over again up to 200. If I execute that, this I could do this manually, but this just makes it easier. So if I run that using Python, it will do those calls, and you will start to see something interesting. So First, we get all the values we saw locally. We can here we suddenly find the decoy flags. And if we scroll down, we can see here. This is the first argument to this application. So we are now running out of the memory space for the application itself. And now we are leaking into the environments because these are the environment variables on that running machine remotely. And this is actually where we can find the flag inside the environment variables. So I was able to leak out the memory from the machine using this exploit, which is pretty fun. And that's all just because we did the printf to a input buffer. So that's another one. Let's see, how much time do we have left? 15 minutes. Okay, let's do a couple more. Any web people in the audience, or are you all like native people? Dabble in a bit of web? Okay, let's do some web because it's kind of fun. Because web developers, there are some concepts that they are not always aware of, such as client-server separations and stuff like that, for instance. Let's see. Any of you know PHP? A couple know PHP. Let's do a PHP one because it's quite fun. So let me see. I have to go on the web. So this is the CTF that I built. That was the Christmas version, but I'm going to go to the other one that we hosted in DNB. It's let me use this one, I think. So it's basically an open web app where you can sign up and you get presented with a bunch of tasks. Why is it windy on the internet today? Let me try again. Let me use this one. Maybe it's faster. Did somebody hack Google? Oh, come on. Okay, forget about that. Let's do receipt. I know the address. What? Is it running? Why aren't these working? Did somebody hack me while I was here? Here we are. Okay. So this is a PHP application. I think we can verify that by using a tool called WhatWeb, which would make out the calls and check the headers and stuff, do some recons for us to figure out what we are talking to. So we're using seems like it's on a Linux machine and it doesn't know what it is. So let's see if we can find out something from the source code. Let's do elements. We have a form action which goes to upload PHP. So now we know for sure that we are working with PHP. It says that we made a nifty upload tool where you can upload images. It says select an image over receipt to upload. So I have prepared an image. Let's see here. It's called hackcat. Let me just choose that. Ikke slektstreff. Where's my home? Okay. Okay. That's okay. Everything is going wrong. That's bad. Let's do code. Here we go. Okay. So I have, let's see, a hackcat. So I can upload that image. And it says it's a genuine image JPEG, and it's available here. And I can click on it, and I will see that image. You also see that it's in the uploads folder, and it's named something, seems like a random hash value or something like that. So this is interesting. Does it only allow images? How about I let's see what this thing. what happens if I upload this PHP file? Would that work? That would be pretty fun if it worked. So let me see. So this is just a PHP file that prints out PHP info. So let's see if that works. Sadly, it's an invalid image. So it means that they do some backend checks to see if this is truly an image. Okay, but what can we do? Well, images, they have binary data, but they also have something called metadata, which is usually in plain text, and it's called EXIF data. It's basically this thing when the image was taken, the dimensions, sometimes it's what type of camera and all that stuff. But we can add our own data to this. So if I just do this, as a comment, and let's do some PHP code. PHP info, execute that. And I do that to hackcat. If I now do exit tool on hackcat, you can see that I have the comment. And I have PHP info. So I have PHP code inside the image. If I upload this thing now, maybe something fun will happen. Let's see. It's windy on the internet again. There we go. So it figured out the image, and if I click it, sadly nothing happens. So we will have to get the server to interpret this as a PHP file. How can we do that? Well, the PHP, the web server basically just looks for the extension that we're trying to for the file we're trying to access. And if that is PHP, it will send that to the interpreter. At least that's the standard configuration of PHP servers. So what happens if I take the hackcat and I rename it to hackcat PHP? Will it fail then? Let's see what happens. Yeah, I take the hackcat, which is now a PHP source file. It's still the image. It only has the PHP inside the metadata. It still looks like a cat. And if I click now, maybe something fun will happen. And surely it will. PHP will just screw up everything for you, because now it went inside that image and said, I don't know what this is. I don't know what this is. Hey, PHP, I really know this. And it starts executing. And now I was able to execute arbitrary code inside metadata in an image I uploaded, which is quite fun. And we can build this further. We can instead of PHP info, I could do shell exec, and I can add some. Let's do ls dot, for instance. Let's see what we get. So now I'm checking if that works. Let's see. It took the cached version. That's not the one I wanted. I forgot to copy that. I needed to do that. Change the extension. So let's see what happens now. And now we can see it's not that easy to see, but here, something.jpg, 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 and something.php. These are the other attempts that I uploaded. So now I can just build this exploit. So let's do up one level, or let's do the root level up one level. See what we can get there. I need to copy it. Now let's see. Now I'm just browsing the file system using image of a cat, which is kind of fun. Yeah, so there's more images and stuff. The way what will happen is I will search through the file system, and eventually I will find. I forgot a dot, I guess. Yeah, I forgot a dot. And eventually I will find the file I'm looking for, which usually is called flag.txt. Let's see. So here we have flag.txt. Now I know where it is. So now I can change this to be, instead of ls, I can do cat with the cat to get the flag. So now, let me see if I can upload again. And there we go. And here we can find a flag, which is watch a lot of Mr. Robot. And if my portal was working at the moment, then I could go copy that and exchange that for points, and I can see my name on the scoreboard, and I can see how many points I got as well. Let's see, do I have time for one more? How many, do we have 6 more minutes? Oh, okay. Let's try. Let's try, because this is pretty fun. How hacking works. Let's do the calculator. So we have this one. No, let's do this one. Yeah, this is fun. So this is another service that's running in our Azure hosted environment. It's one of the tasks. It is if I do some recon what web on this thing, I can see that we are running something powered by Express. So this is a Node.js application, meaning JavaScript, which is awesome because you can have so much fun with JavaScript. And this is a pretty uneventful page. It's just this list of these mythical characters. But if we look inside the cookie jar, we can see that there's a cookie set. You can also see that, find that in the network traffic. You can see that the set cookie header is set once the application is loaded. And this is a base 64 encoded string. So if I go to base 64 and decode, we can see that this looks like an object. It says username Santa, country North Pole. So if I do Espen and I encode that to base 64 and I replace that cookie in my browser, that cookie is sent to the server on the next request. And if things are working as they should, you will see that this nobody will change to be Espen. I'll do that and do a refresh. You can now see that the server thinks I'm Espen. This is something we can use to our advantage because there is that means that this is a JavaScript object, as you can see, and it means that this is serialized, and then it's probably deserialized on the server side. And there is a great package in the Node world called Node Serialize, which is this thing. It still has 555 weekly downloads, which is mind-boggling, but it has this unique property: serialize an object, including its function into JSON. Somebody thought that was a great idea, if you can serialize both behavior and data. Well, that's a horrible idea because JavaScript has something called an immediately invoked function expression, meaning that you can define a function. It's like this. So you can say a function, I can give it a body and do console.log, but I can also immediately invoke it, meaning that that function will just be evaluated as soon as it hits the interpreter. And yeah, well, I didn't log anything, but if I did, it would be like this. So then you can see prints that out. So if I serialize that, and it's unserialized on the server side, well, then the server will execute my code, which is pretty neat. So if I do, and let's do calc exploit. So basically, this application is not the calculator. I'm doing the serialize. Let's do unserialize. I have there we have the exploit. Trying to go fast. So this is the same object, and I've included a new property called RC, remote code execution. This is the syntax that library uses to tell that this is a function. And then I just have the text of the function that I want to invoke in this case. So what I'm telling it is to spawn a child process. I'm starting bin bash. I'm piping that to this IP. And if I run up my trusty terminal application here and I enter my my machine called Arne, which is running in Azure. And I can set up a netcat listening port. I can take, let's do regular cat on that exploit. I can take this exploit. I can take it here. I can encode it. I can take that, and let's do this back here. And let's see, I can take this cookie, replace it, and if, let's see, where's my, if I can do this. Yeah. Now you can see my terminal here, and you can see I've replaced the cookie. So what happened now is you can see that the server called back to my shell, and you can see I'm no longer in Arne, I'm in Node Sandbox. So I now have a remote shell to this server running in the clouds. So I can now see everything. So I can now cat out, for instance, the source code for the server. And here we can find here we can find the secret, basically. So that is pretty neat trick to do. And all just because somebody used this library. And this is not even a vulnerability. It's actually by design why this is possible. Okay, so let me just quickly wrap up. Let's do from this slide. If you want to get started with CTFs, there are a bunch of free ones or ones on the web that you can use. There's Hack the Box and Try Hack Me and Pico CTF. They always post new tasks and challenges all the time, so it's kind of neat. Google has a CTF they do yearly, which they use as a part of their recruitment process. But it's also open to the world, so you can have a go. They are usually pretty difficult. If you want to get started, let's say, have a fun team building evening, you can download something called the Juice Shop, which is based on the OWASP top 10 vulnerabilities. It's basically the world's most insecure application. It's this turnkey thing that you can download, run as a container image. And it's basically a web store, which you can hack, and as you hack, you will find the scoreboard and you can get points. It's pretty easy. We host Hack the Bank on occasion, so you can try that. Last year we had a Christmas calendar Hack the Bank as well, which was really fun. And all the major security conferences, such as DEF CON and Black Hat and so on, they have also these CTFs, and they are like the Olympics. They are really difficult, and they have really knowledgeable people participating and doing the stuff. So key takeaways is that CTFs, they are really fun and educational. And when you build these offensive skills in your team, you start to be more aware of security and how you build your applications. And I encourage you all to go back to your places of work or your pet projects and try these things out for yourself to see what you can figure out. And just put on your hoodies and hack, because it's really fun. Thank you so much. Do you have time for any questions? Any questions? Okay, wait for the microphone. We have one there. Who was the question? Who? There.
Yeah, just how do you know that downloading all these tools for hacking isn't hacked and you're downloading viruses to yourself?
Well, you can actually use the tools to investigate the tools themselves. Most of these tools are open source, so you can actually vet the code, which I encourage you to do. And they are community driven, so if there are vulnerabilities in them or exploits in them, that will be pretty picked up pretty fast. But there may be some of these tools that have things built into them that are malicious. So you have to be smart about how you're using them, which is why I use VMs and stuff when I'm doing these things. Yes, another question? Yeah, one in the front.
Thank you for a good presentation. Is there some, this activity, would it kind of trigger some events from the government or stuff like that?
Funny story. Yes, they will. If you do CTFs, they are usually benign and they don't trigger these kinds of things. But if you are using a corporate computer and you're using these tools in a malicious way, you may get a call from your cyber defense center or something like that, which I may have had happen on occasion. Actually, I gave a workshop edition of this thing inside in DNB, and I actually triggered a full incident response from the CDC team because I did some port mapping and stuff, and I got a call from them, and then I can hear it on, and oh, it's just Espen again. So yeah, so you have to kind of be smart about how you're doing these things. Great, thank you. There's a party, I guess, so the only thing left to do now is to drink beer and have fun. So